Okay, welcome all. It's a good group. This is the week 2 webinar of our online statistics class. And what I want to do is I'm going to share my desktop and talk about the plan of the day. Okay, so here's our plan. I'll start out with any questions you might have. And then after that, we'll get into what does it mean to say probability? What is the definition of a probability? So that's a very deep definition. We're going to do the easy way of looking at it, though. And then I'm going to give you an example of probability, kind of a fun one, and that is lottery. See how that goes. Hopefully well for me. And next will be and or. So how to look at the words and how to look at the word or, and to interpret those and come up with equations based on the words and or when they appear in a word problem in probability. So we'll talk about those. Then the next word we'll talk about is given. So when you're given information, how do you know, how does that change the probability? And we'll talk about that also, and we'll have a formula for that. A lot of equations today. Today is a lot mathier than last week, by the way. Last week was a lot of vocabulary, and today is going to be a lot of computations, a lot of numbers to deal with. And then after that, we're going to get into how to tell whether two events are independent and how to tell whether two events are mutually exclusive. And that will take us through chapter 3 of probability. So then after that, the plan is to talk about project 1. Project 1 is one thing, it's a big part of your grade. It's a big part of the learning also. And it's your first chance to truly work together. Okay. Yeah, you can, talk together outside of class or whatever, or even in the webinars, but here you have no choice. You're going to have to work together on project 1, and I'll explain all the things you're going to have to do for project 1, talk about timelines, talk about what a good project looks like, okay, and the process for completing the project. So that is the plan of the day. So let me ask you, are there any questions about anything that might have come up over the last week about the class or about statistics that you've been thinking about? And again, one of the big things about the webinar is that it's your chance to get immediate answers when you ask a question, because I'll be able to answer immediately. Whereas if you post on the Q&A forum or send me an email, it might take a few hours, okay? Not a few days, that won't happen, but a few hours could definitely happen. So any questions at all, you can post in the chat box, or you can ask, and I'll be happy to address them. And if not, that's okay too, but always happy to answer questions. You're all pretty quiet. Okay, if there are no questions, then I will move on. And I want to remind you, if you have a question that comes up in your mind in 15 minutes, that's fine too. Okay, but I always like to start up if you have questions. Okay, so the next thing is probability. Okay, and I want to give you a heads up. It will not, most people do not find the probability webinar that difficult to follow. But most people find this chapter the hardest chapter in the book. So there's a big difference between watching me do a probability calculation and you having to coming up with the probability calculation by yourself. So I want to give you a big warning is that you might feel really comfortable in this webinar. That does not mean that there's an easy chapter. Most people find this difficult. I do my best to try to make it not look so difficult, but but it's up to you to practice, 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 practice until you get good at it. Unlike last week, there aren't that many ideas to talk about. What's hard is to translate words into equations. Okay, and that's usually hard for a lot of people. So I'm going to start out with the definition of probability, which you've all heard the word probability. I can't imagine you've never heard the word probability before. But if I asked you, what is the definition of probability right now, I guess a lot of you would go, well, I kind of know what it is. It's a chance of happening, but that's not definition. Okay, but if anyone knows the exact definition, let me know. But here it is. So let me write down, and we're going to be doing what's called discrete probability in terms of this chapter. And let's make it a little bigger because it's important. I'm actually going to do it in a bright red color. This is definition of probability. Okay, so here's what's up. Okay, let's suppose you run an experiment, or there is a population. And that could be of people, that could be of dogs, it could be an experiment where you are doing the following. Here's a fun experiment. Taking a card. These are my cat cards, by the way. So whatever the experiment you're doing, the idea is there's going to be a population. And in case the cards, how many are in the population for these cards? Anybody know? Yeah, in this case, there are 52 cards in this population. Okay, whereas if we did a population of the statistics classes, okay, for the sections that are taking this class, then we're talking about a population of about, I think it's 82 now or something like that, maybe 80-ish. So that's a different population, then it's a people. But it could be lots of different things. Okay, so we're going to do that. The probability of an event occurring is the following. And let me just say probability of an event. Why don't we call it E, just because event starts with E. So we're going to say P. I think you can all guess what P stands for, probability. So P, and the notation we're going to use is we're going to put a parenthesis and then an E. So that's the probability of that event occurring is equal to, and it's going to be a fraction. That's really important to note. Probabilities are fractions. And there's a numerator in that fraction. The numerator is going to be the number of possible outcomes in the event E, divided by the number of the population. And I'll just write POP. P is bad because that already stands for probability, so I'll call it POP. Let's make that even bigger because it's that important. Okay, so in words, let's write this out. So the number in event E divided by the number in the population. Any questions about this definition? Any questions? Okay, so I'm going to do a simple one before we do some harder ones. Let's suppose I pick a card. And we have this deck of cards. And here's the card I just picked. And I'm not cheating. I literally just randomly picked a card. What is the probability that this card is an ace? What do you think? Let's see if you can put in the chat box what you think the probability that this card is an ace. And I want a few at least to do it. Getting a couple different numbers. Let's see. Okay, 3 different. Interesting. 4 different. We're getting all kinds of different values. Okay, so let's talk about it. Let's talk about it. We need some help here. First thing, if you're not familiar with cards, that's okay. I will never test you on a question about cards unless I explain what the deck is. So I'm not gonna assume you know about cards. In the old days, everyone knew about cards, but that's not true anymore. It's interesting, and societies change. But let me explain. So the probability that this is an ace are the number of aces in the deck divided by the number of cards in the deck. The population is the number of cards, all the cards in the deck. So the first thing is, how many aces are there in the deck? Good, I'm seeing a lot of right answers. 4. Okay, and if you didn't know that, that's okay. You're not responsible for knowing how to play cards. But there are 4 aces in the deck. And as I mentioned before I even asked the question, is there are 52 cards in the deck. So the probability of, let's type this out. Now it's not red anymore because this is not the big definition. So the probability of an ace, make it a nice equation looking thing. So the probability of an ace is equal to the fraction 4 in the numerator and 52 in the denominator. Just a note, and this is important, you have choices here. You could say 4 over 52. I don't know who it was, but somebody said 1 out of 13. Those are equivalent, and they're interesting. Which is better? And the answer is, depends. So if you want to show what's going on with this probability, then 4 over 52 is much better because it shows that there were 4 aces and 52 cards. If you want prettier numbers, then 1 over 13 is better because not smaller numbers. Okay? If you want to deal with calculators, neither of those are good. Instead, you divide 4 over 52, or 1 over 13 you choose, and you get 0.0769230769. You get a decimal. And that's better if you're interested like what percent chance is, because then you can talk about it as a percent or a decimal. So it really depends. For the homework that's online, I mean, everything's online. For the homework that is the kind of computer-generated homework, make sure you read the instructions. If it asks for a fraction, give a fraction. If it asks for a decimal, give a decimal. If it wants reduced, make sure you reduce the fraction. Is that clear? Okay, and that's not just true for this chapter, but for all the chapters, make sure you read the instructions. Yeah, there's a lot of ways of writing 4 out of 52. And they're all correct, but computers aren't usually good enough to fully understand, so you should do what it asks for. Okay, and if you don't do what it asks for, it'll maybe mark you wrong. So I want to let you know ahead of time. Any questions on this probability example? Nice and simple, right? Any questions so far? Okay, let me do a fun example. Okay, much harder for counting though. And here's something I did today is I went to 7-Eleven today. And this is what I got. Can you all see what I got? Yep, there's a lottery ticket. Okay, and in fact, the person I've never done this, it's the Fantasy 5. Usually I actually buy a different one. Yep, these are lottery numbers. Okay, and I think I'm the only person I've ever met that actually buys a ticket for work. I can actually deduct this on my taxes. See, you saw it? And this is my job, so I can deduct it now. All right, but here's the question I have for you, and I bet you can guess. What do you think my question is going to be? That's your question. Will I share if I win? Normally, I would buy you guys dorms, but it turned out when I went to look at the lottery, um, then the high amount things were terrible today. So I'm a mathematician, I'm a statistician, so I bought the lottery ticket that was the best, and Fantasy 5 today was the best. Just to let you know, so you can buy a lottery ticket. Fantasy 5 is the best one today. That won't be true next week probably. Okay, so the question is, what is the probability that I won the lottery? And just note, I do this every single time. Okay, every single time I teach. I've been teaching for a lot of years. How many times do you think I have won? How many times do you think I had a winning ticket? Okay, this is a trick question. The answer is twice. Okay, the answer is 2 times, but I won like $2 or $4, I think. So I want to go for a win. So now I'm gonna say that's not good enough. I'm greedy. A win means the grand prize. Okay, so a win means. So in particular, I've never won the grand prize, but I have won the little silly $4 winnings. Okay, and that's going to happen if you play enough, and I've been playing a lot. Okay, another thing, if you notice, if you look closely, how many sets of numbers do you see? Not how many numbers, but how many sets of numbers? There's 15 numbers, but how many sets? This is the Fantasy 5, by the way. Yeah, it's 3 sets of 5. So it's 3. So I actually bought 3 tickets. They're all on this one ticket. So I bought 3 for this ticket. Does that make sense? Okay, so that's going to be important in a minute. Okay, so that's just something to note. All right, so to find the probability, definition isn't that hard, is it? So the probability of a win, I don't need it to be 30 anymore. Let's go there. And when I say win, that's the super win, is equal to well, it's a number of events that can happen to make me win divided by the total number of possibilities. All right, let's do the easy part first. How many different ways are there for me to win with this ticket? The hint is it's very easy. Yeah, 3. Okay, and the reason I bought 3 is I didn't want it to be a 1 because then you think it's always a 1. So the numerator in this case is a 3 because there are 3 different collections of numbers that they're going to pick in California somewhere, Sacramento probably. that will make me win. Now comes the really hard part. How many ways are there for numbers to be picked? And just to note, this is the Fantasy 5. First time I've ever played the Fantasy 5. Okay, I usually do Mega Millions or Super Lotto, and those actually, the probabilities really sucked. Okay, the what's called expected values, which we're going to be doing next week, sucked for those two, whereas Fantasy 5 expected value was high. Okay, and by the way, I don't know if anyone looked at my post on the discussion forum for the 3 truths, 1 untruth. What was one of the things that I did to make money when I was younger? Anyone read it? I know it was a while since you looked at it. Yeah, it was a card counter. Okay, so I actually was always looking at probabilities and coming up with the best possible strategy to win. Well, you should do the same thing for the lottery. Okay. Yeah, it was a card counter, and they did threaten my life, by the way. So I've already posted that. I posted that on Sunday morning, so to this morning. So similarly, we want to look at the best possible lottery. Well, guess what? I did the calculation when I went to 7-Eleven, and I found that the best game for the day was Fantasy 5. Now, my guess, any of you know how Fantasy 5 works? Okay, my guess is probably nobody, but you never know. Maybe some of you are like extensive players or something. So if you don't know, I hope you do know how to find out. How do you find out? Yeah, Google. And I Googled it. And here's Fantasy 5. And I clicked how to play. Step one I did is I picked 5 numbers, or let the cashier pick my numbers, which is actually smarter, by the way. And they're from 1 to 39. That's the important thing. So we're looking at 5 different numbers from 1 to 39. And they're picked without replacement. So for example, I'm not going to get the number 7, and then the next number will also be 7. You can't pick the same number twice. Got it? So now, how many different possible picks are there if you have to pick 5 numbers from 1 to 39? I'll be shocked if any one of you really knows that. Okay, it's definitely not 195, by the way. Okay, it's a big number, by the way. Okay, well, you don't probably know that, but here's the math. So if you want to figure out how many ways there are of picking a bunch of numbers out of a big group, then what you do is we're going to do what's called the combinations, which is called NCR. There's different ways of typing it. It's also N with an R below it like this. The formula, which you don't have to know, is N factorial over R factorial times N minus R factorial. And I'm using calculator soup. I probably should make my own calculator for this one. But I'm using calculator soup on this one. And N, what is N in this case? What's N? Okay, N are the number of numbers to pick from. There are 39. What's R? So what's R? Yeah, R is 5, because we're picking 5 numbers out of 39, but we're not allowed to pick the same number twice. And I let the computer calculate it, and it's 575,757. And that's the total number of ways of picking 5 numbers out of 39 possible numbers. So that is the denominator, 575, 757. It's kind of a pretty number, isn't it? 575757. Okay. Neat thing about this kind of stuff is numbers are often pretty. All right, so I have 3 out of 575,757 probability of winning the grand prize of the Fantasy 5. So what do you think? Should I put a down payment on a house because I'm going to be able to buy it in cash tomorrow? Or not tomorrow, Wednesday is when they pick. What do you think? Is that likely? Is it time to go to my realtor? Winning's not enough. Actually, if it's a small house in Tahoe, you can buy one. So maybe a kind of a smaller 3-bedroom house in Sierra Tract. That'll do it. Okay. Even my house, I think, have a 4-bedroom house near the college, and that's about what it's worth. And it wasn't worth that when I bought it, by the way. I paid almost nothing. Okay. Now I could win, but probably not. Wanted something really crazy, and I didn't plan this, by the way. So if we want to look to see how much this is worth, it's 557. There's those numbers 5, 5, and 7 again. Okay, so it turns out the denominator is 575, and I win 557. So it's almost an even bet. Just let you know that. There are some issues, and one big issue is taxes. I will pay a lot of taxes. But, whereas if I bought the other tickets like Mega Millions or Super Lotto, my what's called expected value, which is kind of if I bought all of the tickets, how much would I expect to win or lose? It would be much worse with the other games today. Whereas there are other times when actually the Mega Millions pays a lot more than they do now. So it's always a good idea if you're going to play the lottery, you should do the probability calculation and see whether this denominator is close to the amount of money you're going to win. And if it's really far from the amount of money you're going to win, if it's really below it, then it's a really bad bet. If it's really above it, it's a good bet. And here it's pretty close to the same. Okay, it's not that far different. Okay, still not great because of taxes. You pay 60% in taxes or something. Any questions on this example? Okay, so I'll take it if they'll give it to me. You never know. Maybe Wednesday I'll be like, yeah. But my probability is pretty darn low. Any questions on this example? Okay. All right. Let me do another example. And let's do the card example. And again, if you don't understand cards, that's okay. I'm going to explain how cards work a little bit. Okay. So let's suppose the following. We're going to pick a card now. Okay. And there it is. In fact, let's do it a little differently. I'm going to grab 2 cards. And hopefully you can see, what does that add up to? If you add those numbers, yeah, 10. Now you see those 2 cards. We got a 4 of diamonds and a 6 of clubs. Okay, those are our cards. And we're playing blackjack. So again, you don't have to know much about blackjack, but I'm going to tell you a few things. The dealer has this guy showing. All right, so what happens with blackjack is that if I can get a higher total value that is 21 or less than the dealer gets, then I win. If I get a lower value, I lose, and if it's a tie, then it's even bet. No win, no loss. Okay, the dealer has a card that I don't get to see. Is under. So there's the dealer's card. We have to decide what to do. Do you think we're going to win, or do you think we're not going to win? Okay. So the idea here is, let's suppose I'm going to feel like I'm going to win if I get either a face card or an ace. Got it? Okay, an ace is going to give you 21, a face card is going to be 20. It's more complicated than I'm saying, but that's what I'm going to say. Okay? So I'm going to just pretend that if I get a face card and an ace, then I'm going to find that, yeah, that's when I'm going to feel really good about it. Okay? Yeah, equal or smaller than 21, but you got to be better than the dealer. Okay? So the idea is we want the probability of a face card. Okay, I'm going to write value 10 actually. Or ace. Any questions so far? Okay, and in fact, I'm going to take that or, I'm going to make it capital because I want to emphasize the word or. So when we have a probability with the word or in it, then there's a formula that we can use with an or probability. And that is the probability of a value 10 plus the probability of an ace, and then minus the probability of a value 10 or ace. I'm sorry, and ace. Okay, so this is a very important formula. When you see the word or, you can always put these together like this. You can add the two and then subtract the both. That's what this means. Okay, so now let's calculate. This is equal to, well, probabilities in a word are fractions, remember? How many value 10s are there? And if you don't know cards, that's 10, Jack, Queen, or King. How many value 10s are there total? 10, Jack, Queen, King times 4 is 16. All right. How many cards are we picking from? How many cards are you picking from? All right, so I'm a card counter. Okay, I have seen these two cards. I have also seen this card. So it's not a 5 of hearts, not a 4 of diamonds, not a 6 of clubs. This card is upside down. I don't see it. So it doesn't take anything out. So I'm actually taking 3 out of the pile that it can't be. So 52 minus 3 is 49. Any questions on that? Anyone lost on this idea? Then I go plus. Now probability of an ace. Okay, well, let's do probability of an ace now. That's a fraction. What's the numerator? Yeah, 4. There's 4 aces. And again, there's still 49 cards it could be. Minus, what's the probability that it's both value 10 and an ace? So what's the probability that this card right here, the next card in the deck, is both an ace and value 10? Yeah, 0. So in this case, we're subtracting 0. Okay, that won't always be the case for other examples, but I wanted to remind you when you have an or, we have this formula. Any questions on that? Okay, and that's 20 over 49. I figure I don't need to do the math for you. Why is it 0? Because this card can't be an ace and value 10. If it's an ace, it's not value 10. If it's value 10, it's not an ace. Does that make total sense? Yeah, so the card can't be both. So I want to let you know that if you're counting cards, then your probabilities change, because if you've seen a whole lot of cards and you know what came up and you know what they are, then you can bet based on your probabilities and change your bet because you know more. Okay. Why can't I do that? Anyone know? Because the mafia said they'd kill me if they ever saw me back at the casino playing cards. So no, I'm smarter than that. I'm not going to die playing cards anymore. But I did make thousands of dollars counting cards. So just an idea is that, if you could do these kind of probability things, and by the way, you're not allowed a calculator in a casino. You do it in your head. But if you could do it, then you can make a lot of money. Okay. On the other hand, I did work for the casino afterwards because they hired me so that people like me can't win. And I helped them change the rules. But when I was younger, they had rules where I could win. So just let you know. And it wasn't just me. I'm not the only one that helped them. But I was one of the statisticians that helped them change the rules. So if you lose in the casino, it's my fault. Just let you know. They're there to make money. Any questions on this example? Not too bad? Okay, so let me give you another example. Let's suppose I'm now going to pick 2 cards. Okay. What is the probability that if you pick 2 cards, that both are aces? Okay, so now we want to find out what's the probability they're both aces. So we're going to use what's called the multiplication principle. And what it says is the probability of 2 events occurring when they are chosen without replacement. So in other words, I pick 2 cards. They can't both be the ace of spades. So the first is an ace of spades, the second is not. Is the product, and product means multiplication, of the probability of the first occurring and the probability of the second occurring given the first occurred. So in symbols, the way you write that is the following. So the probability of, let's go B, and then I put a little line, a vertical line segment, and that's read given A. Sorry, probability of B, A, that one more, A and B is equal to the probability of A times the probability of B given A. Okay, that's called the multiplication principle. Any questions on that formula? And B given A, that means what's the probability of B happening if we know that A happened? So in our example, probability of two aces okay, that means the first is an ace and the second is an ace, is the probability the first is an ace. Well, what's the probability the first card is an ace? And it's a fraction. Probabilities are fractions. What's the probability the first card is an ace? Yeah, 4 out of 52. And then we're supposed to multiply it by the probability that the second is an ace given the first is an ace. So what is the numerator? If we're told the first card was an ace, we want to find the probability the second card is an ace. What's the numerator? Yeah, it's 3, because there's only 3 aces left. What's the denominator? 51. And that's the answer. You can throw it in a calculator. I don't think I want to waste your time, you know. Hopefully you all know how to put fractions in a calculator. Any questions at all on dealing with these givens? And this little horizontal lines, vertical line segment is read given. So it's probability that B occurs given that you know A occurred. Any questions at all on the multiplication principle? Okay, there's a lot of little formulas and principles. And again, I want to warn you again, it's this will be the second time I've warned you, but I want to give you an analogy. Probability is like kickboxing. Okay? Have you ever watched kickboxing? What do you think? How painful is it to watch kickboxing? To sit in front of TV and watch someone kickbox, or sit in front of a ring. Okay, if you're watching it, not doing it. If you're watching it, it's not painful, it's easy, no problem. Do you agree? But if you're in the ring, does anything change? Yeah, trust me. I've taught a few things. Karate is the other. And I have done a lot of kickboxing, not recently, but in my younger time. And so probabilities like that, watching me do it is really easy. You just see it. Hey, I wrote down the fraction. That was easy. But doing it yourself is much harder. So I want to warn you, you're going to want to practice this stuff. Any questions at all on this? Okay, 2 big definitions. Let me put it in red because they're important. Events A and B are mutually exclusive. if the probability of A and B equals 0. Then we say they're mutually exclusive. They can't both happen. So for example, we had before that if I pick a card and you let A be the event that it's an ace and B be the event that it's a value 10, that probability, the probability of A and B was 0. So those were mutually exclusive. What if A is the event that the card I pick is a spade and B is the event that it's a jack? Are they mutually exclusive? So if A is that it's a spade, B is it's a jack. So if A is the event that the card is a spade and B is the event that the card is a jack, are they mutually exclusive or not? They're not, because the probability of A and B is 1 out of 52. See if I can find it. Not cooperating. It's in here somewhere. There it is. That was the card I picked. Because the jack of spades is a possibility. So that means the probability is not 0. The numerator is not 0. So in particular, they would not be mutually exclusive. Any questions on that? Okay, the next definition. And that is events A and B are independent if any of the 3 are true. So the probability of A and B is equal to the probability of A times the probability of B. Probability of A given B is equal to the probability of A. And the probability of B given A equals the probability of B. Okay. So notice that the second one says that if you know about B, it doesn't give you any information about A. The third one is if you know about A, it doesn't give you any information about B. And that first one says the multiplication principle gets a little simpler because you don't have to deal with B given A. You just have a B there. And if one is true, they're all true, by the way. So it's all or nothing. And that's just a math thing. Any questions on that? Any questions? Okay, and independence comes up a lot. Can you think of any reason why you might care about independence? Let me give you an example. Suppose, let me do an example, not in red anymore. Okay, so let's suppose let A be the event that a person is hired for a job. And let B be the event that the person is an underrepresented minority. What would we like to be true? Okay, someone doesn't want red. I won't use red anymore. Yeah, we'd like them to be independent of each other, because if they're independent, then you don't have racial discrimination. You don't have bias, right? If you're going to hire someone for a job, then you're not supposed to say, well, you know, that person's the wrong color, I'm not going to hire them. So if you want to find out if racism is occurring, what you do is you calculate these probabilities, see if you have independent events, and if you do, then you don't have any issues with racism. If you don't, then you have racism. Okay, so that's an example, you know, a real life example where people look at these things and, you know, use this probability to find out if there's any issues. Any questions on that? Okay, let me tell you an issue. What I use a lot for making money is I want to find events that are dependent in the stock market. And if I find events that are dependent that other people haven't found yet, I make lots of money. And that's how I use statistics to make money. Money's always, you know, nice to make money. Okay. Whereas lottery, this was just so I could give you an example. I never played a lottery to win money. But stock market is different. And stock market, if you can analyze independence, find out there's a dependency relationship, and you can use that to make money. Any questions on why you care about this stuff? Any questions? Okay, let me give you one more example. So so roll 2 dice. And there's a 6-sided, by the way. And they're fair, no cheating allowed. So you want mutually exclusive in the stock market? Your goal is to make money? Mutually exclusive doesn't happen, just let you know. What you need is you need dependency where you understand the dependency and others don't, so that you can make money on it, because then you know that you have a higher probability of winning than money, and other people don't know about it, and you can buy at a lower price. Just to let you know. Okay, but we're gonna do something simpler. Okay, it's very complex to do that. Here's something much simpler. We're gonna roll 2 6-sided dice. Okay, let event A be the event, or be that the first die was a 6. And let's let B be that the sum of the 2 dice is 7. Are these independent? Okay, and let me ask you, I'm not writing this out, but are they mutually exclusive? That should be easy to find out. Are these mutually exclusive events? Okay, and the answer is no, because you can get a 6 and then a 1, and guess what? I just got a 7. Probability is not 0. Got it? But are they independent? So when you're doing independence, you have 3 choices in terms of testing. What do you think is easier, the first, second, or third? I have 3 equations. I could pick whatever I want to test. Any thoughts? Okay, it turns out the third's the easiest in this case. And you could try all 3, but we're going to find out the third is the easiest. Okay, so let's do the third. Let's find the probability of B given A. Okay, so now I'm going to make fraction. What is the probability of B given A? I don't have enough time to explain why that's the easiest. You can try all three, you'll find out. So again, that's where practice helps. So probability of B given A. Okay, well, if you know that A happened, so you know that the first die landed at a 6, what's the probability the sum is going to be a 7? Well, so if you know about the first die, then there's only 6 outcomes for the second die. How many of those outcomes make the sum to be a 7? 1. Right? That's if that second die was a 1. There's a probability to be given A. Now let's find the probability of B. So that one, now we want to find out the probability that the sum of 2 dice is a 7. So let's work this out. Gonna have a fraction as always. All right, we can have a numerator and denominator. I'm gonna do the denominator first. If you roll 2 dice, how many different possibilities are there? How many different ways of those dice landing are there? And the idea is you could have a 1, a 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. That's 6. You could have a 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. That's 6 more. Okay, and I could keep going. There's 6 choices of 6 each, and that gives you 36. Any questions on that? Okay, now how many different ways are there of getting a sum of a 7? Well, let's count them. A 1, 6, a 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1. There's 6 different ways. So let me ask you, is the probability of B given A equal to the probability of B or not? What do you think? Now you got to be able to do fractions. Yes, 1 6 is equal to 6 over 36. Those are equivalent fractions. So that tells us these events are independent. Okay, had we gotten different numbers, they'd be dependent. So for example, if I said the sum of the dice was a 9 instead of saying it was a 6, they turn out to be dependent, or not independent means dependent. So I can give you all kinds of different combinations. Sometimes they're independent, sometimes they're not. You have to do calculations. Equal, not similar, equal is the right word. So if the fractions are equal to each other, they're independent. And 1 6 is equal to 6 over 36. Any questions on that idea? Okay, so there's a lot to probability. Again, it's a lot easier to watch me do it than it is to do it yourself. So practice, okay? Make sure you get this all down. Post in the Q&A forum if there's a problem from the homework that you're not getting or you're not understanding, and I'll answer it pretty quickly. Okay, now what I want to do, I think maybe I'll do this now because no one's going to leave. You'd be foolish if you left now. I'm going to give you the secret word. And there was a request not to do it in red, so I won't. keep it black, but I'll make it bold. It's a very short word, and it's or, because or was a kind of a keyword in probability. You want to find out the probability of event A or B, and we had an equation for that. So that's a secret word. And now that we've had that, I'm going to move on. Make sure you write down what the secret word is. Otherwise, you got to watch this again. Okay, I'm going to move on, and I am going to talk about project one. In fact, I think I'm going to show you from home how to find it from your home screen. So there's a few ways. I think the easiest is to go to the syllabus. And there's a few things we can look at. One is project one is due on October 11th. That's a while from now, isn't it? I want to give you enough time. So October 11th is a Sunday. I think it's 3 weeks from today, if I remember right. And it's by nighttime, but I wouldn't wait till the last minute. That'd be very bad for you. So make sure that I recommend truly getting it done before the 10th, by the 10th. And that way, if something goes wrong, you have a whole day to deal with it. So October 11th is when it's absolutely due. I recommend by the 10th, maybe even a little earlier, to get it turned in so that any mistakes that happen, you can handle. And you'll have enough math by now to be able to do it. All right, so there's a few places to look at the project. One is over here, and we saw this when we looked at the syllabus before. So I want to remind you a couple things. Right here, a 25% penalty will be incurred on any student who cannot work with another student. Okay, that's a life skill you need to have. Okay, and again, being an online student is not an excuse for not being able to work with each other. We're in this this isn't even a COVID thing. This has always been an online class. Okay, this was set up in the schedule as an online class. So you need to work together. It does not mean you need to go to each other's houses. It means you know how to work online. Email. I like to use Google Docs when I'm doing a paper together. You can do that. You could do Skype. You could do Zoom. Whatever it takes for you to be able to communicate and work together, that's a good thing. A lot of you have partners already. If you do not have a partner already, you should be worried. You should be concerned, and you need to get one. And what's the easiest way of getting a partner for most of you? What's the easiest way of getting a partner? Yeah. So if your question was, how do I start getting a partner? I don't know if that's what you asked for. Yeah, the discussion board. So again, if you go to your discussion board, you're going to see a lot of people posted. And my strong recommendation is having 3 in your group. There's a bunch of reasons. One is if one drops, you're still okay. Then you're not in panic mode. The other reason, which is really nice to know, is that this is usually around like a 8-page, 9-page paper. So if it's an 8-page, if it's a 9-page paper, and there's only 2 in your group, how many pages do you have to write? Easy math, not too hard at least. Yeah, 4.5 pages. Okay, if there's 3 in your group, how many pages do you have to write? 3 pages. What sounds better? Yeah, go for easy. Okay, go for 3 in your group. Okay, less work. Okay, also more brains, which means that as a group, you're going to understand more statistics. So group of 3 is better than a group of 2. If there's 4 of you, you have to split into 2 groups and then maybe ask for, see if you can find a third for each. So 2 or 3. Okay, so post on the project 1 discussion board. If you haven't already, if I want a partner, and then, or look through it and find someone that hasn't found 2 other people and reply saying, I want to be a partner. Okay. Again, you're all supposed to know how to use the internet. So you don't have to live near each other. That's definitely not important. All you have to do is have the ability to use the internet, which everyone has to be able to be in this class, actually. Any questions on that first thing? Okay, no big deal. Okay, but you got to find the partners. Okay, then what I recommend, and if I click on project one, it's going to give a description of the requirements. I'm going to talk about that, talk about the kind of ways of going about the project, and talk about what you're going to be doing. Okay, the first thing that's going on in project one is that this is a survey. Okay, you're going to be conducting a survey, and it has to be of people. Okay, you need to be doing investigation of people. You have to do something that somebody might contract out to have done. Okay, it doesn't mean you have to go find someone who's going to pay you money for this. But in your imagination, if you can't even imagine someone paying, then it's not a good project. If no one's interested in this, then don't do it. It has to be something of interest to somebody. It doesn't have to be you. Okay, it should be someone, and you should identify who it is that is of interest. And you're going to be writing your project in the tone where you are addressing that person. Okay, and that person could be, again, it could be President Trump. It could be, Governor Newsom. Okay, it could be your boss. Okay, there's a lot of people that might be interested in different things. Okay, so you identify a person that might be interested, and that's what you can be doing. Okay, now we are in COVID times, so I want to mention some things that are not written here because this is kind of my standard project. But I do want to let you know you are not allowed to put yourself or others in COVID danger. Got it? Okay, so if you are going to be asking people in person, you need to be wearing a mask. Got it? If you're going to be asking online, you do not need to wear a mask. Because just like I could have COVID and it doesn't matter, you won't get it from me on Zoom. Okay, but if you're going to be doing anything in person, you have to wear a mask because, again, I want to make sure things are right. The other thing, and I think I mentioned last week, is that children are off limits. Okay, under 18, not okay unless they're a college student who happens to be taking a college class. So for example, if you're going to be asking students the survey question, and one of the LTCC students is 17 years old, their parents have already actually signed their rights away. You may not know that, but that's what happens. So when my daughter took a class, when her first class she took at our college, she was 14, I think. And I had to sign her rights away for her to take the Spanish class that she took. Okay, and that's what it is. So it's safe to ask any college student, even if they're under 18. On the other hand, you're not allowed to go ask elementary school kids because it has to go through an ethics committee. Doesn't mean it can't happen in the real world. It is a lot of work though to make it legal. Okay, so you're not going to be doing that. So no one under 18 unless they're a college student, and then they've signed the rights away, so it's okay. Again, so I just wanted to talk about the legal things first. Okay. So if you ask online, that's fine. You need to use a sampling technique that we did in this class that is basically, it's got to be random, stratified, or cluster. What did I say about random sampling when you're doing a sample of people? Do you remember? I talked about that last week. Yeah, it's almost impossible. So if you think you can do random sampling, think again. That's why I didn't provide a link to that one. Okay, so good luck. But Stratified sampling, that's something you can do. I talked about that last week. Cluster sampling, that's something you can do. I also talked about that last week. Okay. And you can do one of the, basically you can do one of those two sampling techniques. Okay. All right, the very first thing you should do after you have your partners is to get together and come up with your plan. Got it? Once you come up with your plan, the next step is to post on the project discussion board. Okay, make sure you're all in agreement with your plan. And then I will look at it and I'll let you know whether it'll work and what tweaking you need to do so that you can make it work if it's not going to work. Most of the time, there's going to be a little tweaking to do. So what you want to post is how you're going to conduct your study, okay, what sampling technique you're going to do, what survey question you're going to ask, or what data you're going to collect from each person, depending on what it is, and who your client is. You post that on the project discussion board, and I'll help you. Okay, I recommend doing that within a week because it doesn't take long to come up with an idea. But what you don't want to do is come up with your idea, not bother doing the project discussion board, and then work it out because a disaster could happen and then it doesn't work at all and then you don't have a project. But if you post it, I'll let you know if it'll work and then you can go ahead and go and do it. And then there'll be a lot of details you have to work out, but you won't have any disaster. Does that make sense to everyone? So one suggestion I have before you even post on the project discussion forum, which would help, is ask your partner the survey question. Ask them. Could be by texting, it could be by, Zoom talking. What must come out of the person's mouth? And the key is in here. It says, where are we? In the first few words, think of a quantitative investigation. So what must come out of the person's mouth when you ask the survey question? A number. If a number doesn't come out of the person's mouth, it won't work. Okay? So you cannot ask something like, have you ever been to Europe? That's not a good survey question because a number won't come out of the person's mouth. The survey question would be, have you been to Europe? And if you ask me, I'm going to say no. I'm not going to say 47. Okay, so a number should come out of the person's mouth. And a better, by the way, for what we're doing, a better study is that there's a lot of different things that the person could say, different numbers. So don't ask something like, how many times have you been to Somalia? What's the problem with that? Because that's quantitative, but what's the problem? Yeah, just about everyone's going to say 0. You want a survey question where you're going to get a variety of answers. You don't want something where almost everyone will say 0. Is that clear? So how many times have you been to Europe may not be so good because even that, not as bad as Somalia, but still most people will probably say 0 or maybe 1. You're not going to get a lot of different answers. Okay, so try to get something that's going to have a lot of answers. Any questions on that? Okay. And the survey question can be discrete, where you're not even saying the survey question. So for example, if you want to do a survey, if you work in a restaurant and you want to do a survey about what people spend, then you could just look at their receipt. And there's gonna be a lot of different answers, okay? So there are different ways of doing survey questions of people. One is physically asking them, the other is looking at them or looking at their action. Does that make sense? Okay, another thing that somebody asked, and that's up here too, the sample size must be greater than 30. Okay. The reason for that, we're not going to understand for a few more weeks. But trust me, if it's not greater than 30 on a quantitative study, you don't have very reliable answers. You don't have very reliable results. We'll get that another day. Okay, so this is just to let you know that's important. Any questions so far? All right, you must just, after you have posted, and after I've said great, good survey, go ahead and do it. You have a good project. Then you go do the survey. You should, even before you do the survey, you might want to think about what bias might have occurred, but actually usually that happens after. Okay, due to your sampling technique. If you say there is no bias, what do you think is going to happen? If you say there's no bias, what do you think is going to happen? Yeah, you're going to lose points on this test, this project. Okay, unless you could give me a really convincing argument. But pretty much anytime you do a survey, there's bias. So you do not lose points for having bias. You lose points for not identifying the bias. Do you see the difference? We had a suggestion, a recommended sample size like 100. So here's the problem with 100. 100 is about 3 times more than 33. Why do 3 times more work when you don't have to? Got it? I will not take off points, but I don't know. If I have to do extra work and it's not going to give me anything, why should I do it? So I'm not going to give you more points if you do 100 versus 33. Okay, if you do 25, that's bad. As long as you're more than 30, 31 is the minimum. I use the number 33 because if there's 3 in your group and you each do 11, then you don't have to complain that I had to do more than someone else. So that's the smallest number that's a multiple of 3 is 33. Okay, but if you do 35, that's fine. 100, I think, is more time than you need to spend on it. Okay, in the real world, more is better if you can, but also more expensive, so not always better. But for this project, over 30 is the requirement. 31 is the absolute minimum. Any questions so far? Okay, really good questions I'm seeing in the chat box, by the way. Okay, now, what do you include? After you do your survey, what I would recommend, what you need to do is you need to create charts. And the charts must have a histogram. They must have a stem and leaf. And they must have box and whiskers. Those are 3 requirements. If you can ask a survey question that has more than 1 digit as an answer, like I said, bigger variety, then box and whiskers will be more, then the stem and leaf will be more interesting. Any questions on that? Okay, are you going to draw those by hand? What do you think? Okay, definitely not. Okay, this is supposed to be a professional project. Professionals don't draw by hand charts. You need to use a computer. Is Google Forms okay? For the survey, you mean? Yeah, Google Forms is fine for the survey. And if you want to use Google Forms and you don't know how, ask me, I'll help you, because I am an expert in Google Forms, by the way. If you want to use Google Forms, you can. You don't know what that is? Ask your partners. Hopefully one of you knows what it is. And if you don't want to use Google Forms, that's okay too. It's not necessary, but it is allowed. Okay. So again, you have to have these 3 things. Also, you might want to include a pie chart or a line plot, other kind of plots that might be interesting only if they're relevant. These 3 are required, the others are just maybe, not necessary. Okay. Any questions on that? Okay, as I mentioned last week, you must use a spreadsheet program. I developed that spreadsheet program for this project and the next one too, by the way. So that's one that will guarantee to work. Other spreadsheet programs might be harder to figure out. Can you use Excel? Maybe, but Excel is actually pretty tough if you're not an expert in Excel. Whereas the spreadsheet program, you type in your data and it's there, you're done. You don't have to do anything. It's set up for project one. Okay, you're not allowed to use a calculator. If you said you use a TI-84, I will take off a lot of points. You must use a spreadsheet program. And as I mentioned, you copy and paste a spreadsheet program onto your document submission. And that's proof that you use a spreadsheet program. You need to prove it. Okay. Okay, just a note, there's a common mistake. It's a single column of data. Okay, so if you're doing stratified sampling or if you're doing cluster sampling, and you might have had 4 different clusters, that does not mean you're pairing the 4 things. The sampling technique is used to collect the data. Okay, you're not comparing one type to another. So if you were doing, say, stratified sampling by gender, and you had male, female, and other, then that does not mean you're going to have 3 columns. You're going to have 1 column, and your analysis is not about gender. You only talk about gender when you're discussing the sampling technique. You don't talk about it when you're writing up the results. Okay, you need to discuss the charts. Okay, and what I need you to do for all the charts and all the statistics is to not just say, hey, the mean was 23. I want you to have a recommendation based on that number or that chart to the client to help the client's business or goals. Okay, so don't just say what the first quartile is. Say, how is the client going to make a decision after seeing that value? Any questions on that idea? Okay, throughout the entire paper, not just at the end of the paper. Every time you mention a statistic or a chart, you next mention what decision the client is going to make after seeing that statistic or chart. And if no decisions could be made on anything, then you have a worthless project. You need to start over. So that's why you're going to be posting on the Q&A forum, I mean on the project discussion forum. And I'll help you and say, yeah, this is something that a client would be interested in. Okay, any questions at all? Okay, the number 1 part of the whole project is the standard deviation. Okay, you must have at least a full paragraph devoted just to the standard deviation and how the standard deviation is used and what recommendations are going to be made based on the standard deviation and all the uses of the standard deviation. So things the standard deviation is used for are the empirical rule and or Chebyshev theorem. Okay, talk about those. Okay, that's all in the book. And you need to talk about that. They're used for the z-score. Remember, the standard deviation is part of the formula for the z-score. Okay, by the way, if you do not give me the x value you're using for the z-score and why you're using that x value, why is that x value of interest to the client, then you don't understand the z-score. And it'll be clear you'll lose points. Okay, any questions on that? Okay, this is a paper. So in any paper, you should have an introduction, a body, and a conclusion. That's just standard for papers. So the conclusion is a synopsis, kind of the most important, maybe few things that you discovered from the charts and statistics and the decisions that the client is going to make because of it. That's kind of how you finish off your paper, is the key findings. Okay, any questions on this? Okay, again, I'm not reading this word for word because you can read it word for word. All right, what I did here is I literally copied and pasted feedback I gave from students who sent me their draft and I gave feedback. I recommend you looking at this before you send me the draft so that you have a good project. Now let's talk about the draft. Okay, so for the draft, what I want you to do and what you'll want to do is send me a draft of your project. All right, now I want to let you know, we're talking about over 80 students in this class. Okay, projects typically are like 8 or 9 pages. Okay, what's 8 times 80? $640. Okay, so if all of you send me your draft, I'm going to have 640 pages to read. So I just want to let you know where I am. Okay, I am going to read them on a first come, first serve basis. Okay, if you send me the draft on Saturday, it won't get read. I won't have time. If you send me on Friday, it might get read. I'll do my best. If you send it on Monday, I'll definitely get a chance to read it. Do you see? So the earlier you send it to me, the better chance I'll be able to have to actually read your paper, your draft. Because I have, if you all send a draft, 640, but it's actually not 640 because projects are 2 or 3. So if you divide that by 3, we're still talking over 200 pages. Okay, that doesn't happen in an hour, by the way. Okay, and I have to write comments about all the pages. Okay, so it's many, many hours of work for me. So again, first come, first serve. So if you want me to read it, the sooner you get it to me, the better. Any questions on that? There is someone else in this group right now who will also take a look. And who is that? Maybe you can speak up. I'm looking at you.
Hello, everyone.
Yeah, you know what I'm talking about, Braulio. So Braulio, don't forget, he's our embedded tutor. Why don't you say something, a word or two?
Yeah, definitely. My hours are posted on discussion, so feel free to go to Cranium Cafe anytime that you need help during those hours. And if it's past those hours or some other day off, like just email me. I'll try to get back to you as soon as I can. And yeah, send me your papers. I'm more than happy to take a look at them.
And Braulio has already taken statistics at LTCC, so you had to do these projects, right?
Yeah. Yep.
Yeah. He did go with WIM, but it's not that much different.
No. Yeah. No, the requirements were all the same. Yeah.
I think for this project, I think she copied and pasted mine.
So yeah, there you go.
I don't think she has the feedback link because that one I did after I gave it to her, I think. But anyhow, that's something to do. And then I will send you an email. That's something to do by email, by the way. So you post on the project discussion board your idea, and that helps other people to see ideas too and feedback. But the project itself, email that to me. And then I can give you feedback. Okay. I knew this was going to be a long one, by the way. I am with my watch. It is 7:29 and a half right now. And I'm about done, but so I'm going to, let's see if I can do this. Unshare. And thanks for coming. I'm going to stop the recording.